All right, let's do some circles classwork practice where we're going to use these new rules that you did on the yellow notes. So have those yellow notes handy so that you can look at the pictures and see which one this might look like as we're doing them. Just like we had angle justifications in between parallel lines, we knew certain angles were equal or supplementary, etc. We now have circle justifications. We know that circles equal 360 all the way around the edge. We know that the central angle is equal to the arc measure, etc. We're going to apply these rules. So looking at this first one, I'm just kind of noting a few things. I'm noting that they want the measure of minor arc AD. And they've also given us a diameter, which I'm thinking, okay, that's like a semicircle, right? 180. And they've also given us an outside measure of a minor arc right here, already of 132. What do you think? How could we find that little measure? You got it. Now look at that circle's justification if you need to, as we're going through this assignment, if there's ones you don't understand. But, oops, there it is. We know that this diameter, this semicircle over here on this side, we know that the measure of that arc DCB, if you will, is equal to 180. So the measure of DCB, that's called a major arc, is equal to 180. And that's by semicircles equals 180. Then we know that this other arc given to us is 132. So that's going to be minor arc, the measure of minor arc AB is equal to 132 that was given to us. I know that the whole circle is equal to 360. So couldn't I do that, add that entire thing up, where I could say the measure of the arc I want, AD, plus the measure of minor arc AB, which is 132, plus the measure of major arc DCB is 180. That whole thing equals 360. So I have my unknown here, plus 132, plus 180. So take a minute to grab your calculator. I'm going to grab mine as well. I'm going to do 132 plus 180. That's giving me 312. You need to subtract that 312 from 360. And I got, how'd you do, that the measure of minor arc AD is 48. And these are in degrees as our units. Okay, so let's look at all these circles justifications we just used. We used semicircle equals 180. We used that circle equaled 360. And then there was a given arc as well. Okay, let's go look at the next one. Next one, I'm going to highlight it once. The measure of major arc ACB. And they gave us a central angle. You got it. Central angles are equal to the arc measure. And that means that this 120 right here is equal to this minor arc measure, 120. So I have that little piece. I want the big green piece. Do you see what we're going to do here? Measure of minor arc AB plus the measure of major arc ACB equals 360. And that's that the whole circle equals 360. And so here we go. The one that I have, 120, plus the one that I want, and we just subtract. You got it. The outside big major arc is 240 degrees. How'd you do? All right, this next one we're looking at, you'll start to recognize where this angle goes all the way to the edge of a circle. That's called an inscribed angle. And they're asking us for that angle, measure of angle EDF. They want the inscribed angle, and they gave us a central angle. So this is kind of a two-step process. So if I know the central angle, then I know the arc measure, because central angle equals arc measure. And so I can say that minor arc EF, that's the green one, is equal to 114. And then we have a rule for inscribed angles. Look at your yellow notes real quick. Inscribed angles, you got it, are half the intercepted arc. So see this right here? The measure of angle ACB is half of the measure of the intercepted arc. So we say that the measure of angle EDF is equal to half of 114. So grab your calculator and do that. Okay, that's 57 degrees. And what did we use for that? Inscribed angle theorem. So my two justifications, inscribed angle theorem and central angle equals arc measure. Okay, next one, we've got these two angles on opposite sides and there's some kind of a quadrilateral inside. Let's go take a peek. Again, these are getting more complicated, so you're starting to match pictures. So look at this one on the bottom here, opposite angles of a cyclic quadrilateral. That's where all vertices are on the inside of a circle. Opposite angles in a cyclic quadrilateral are supplementary. So we just add these up to 180. So 110 plus 5x plus 2 equals 180. So we get 112 plus 5x. Grab a calculator and minus that 112. Did you get 68? And that comes out, oh, I guess I don't need bumps. It comes out to exactly 13.6 degrees. Since I didn't have to round, I don't need the bumps. And then what do I write for my reasoning? I write opposite angles in a cyclic quadrilateral are supplementary. Ooh, it's a long one. Okay, how'd you do? All right, next one. We're starting to get into these crazy rocket science names. For example, what's the name of this next theorem? And then I'm like, well, what do I have? I have a tangent and I have a radius. And then we get crazy and we look at our sheet and we notice that we have a tangent radius theorem. Yes, we do. So what does this theorem say that you wrote down yesterday? A tangent and a radius form a perpendicular. That means that that angle measure is 90. And when we have 90, we have lots of things we can do. We can do trig, we can do Pythagorean. Right triangles are our favorite. So this one's showing an example with Pythagorean theorem because we have that 90. And let's go see what the one in our question is asking. So on this one, they want the measure of angle pho, F-O-E. And we know that this over here is 90 because of tangent radius theorem. So we're going to say tangent radius theorem tells us that the measure of angle EFO equals 90 degrees because of that perpendicular. And that means that I can do triangle sum theorem for the rest of it. I say 32 plus 90 plus the angle that I want, we'll call that X, equals 180. And then grab those calculators. I got a 122. Is that what you got? And then take a minute to subtract from 180. Did you get 58 degrees? And so we just found the angle, the central angle, technically, angle FOE is equal to 58 degrees. Okay, last one. Oh my gosh, which theorem is this? Which justification is this? I got a tangent. I got 2 radii. Let's go see what's on our yellow sheet. And the last one is a circumscribed angle and a central angle, where a circumscribed angle is the angle formed outside of the circle by tangent lines. And I'm like, yes, that's what I have. I have an angle formed outside the circle by tangent lines. So what's the rule for this? The central angle and that new circumscribed angle outside are supplementary. Circumscribed angle and central angle are supplementary. So we say circumscribed angle and central angle are supplementary. Okay, so I'm going to say, and I'm going for this one, measure of angle SRT. So X, my circumscribed angle, and 140, my central angle, are supplementary. That's it. These look scary. They have a lot of words, but they're not bad. What'd you think? 40 degrees. Okay, I'm going to stop the video here before the next page, and I highly encourage you to try it without my video and then just check your answers. Thank you. Go get them circles.